that's about it. So. Okay. All right, ours gonna start in 1 minute. So please take a seat, have some fun. Go dive right to it. Also pull out my code so that help limit it. Okay. All right, I think it's 7. So howdy everybody. How's everyone doing? Hope you're doing well. Sorry for being late today. I was outside doing some stuff. So I came back a little bit late, but thankfully it was on time. So that's okay. They need to switch. Swap display. Okay. So howdy. I'm back. Sorry, it you probably see it's kind of weird that it's already week 5, and then I'm gone, and then week 10. So sorry about that. A lot of things had happened, but I'll try my best to continue. So today we're going to talk about PA4. As a reminder, I think it's due next week. So I put together a presentation on the entire PA4 so you can see what exactly you need to do and some hint that you might use for your debugging and your writing the code. So before we start, is there any question I can answer right now, real quick? All right, sounds good. Okay, so then we're just gonna go straight into the yes, it is recorded. Okay, so check to make sure it's recorded. Yes, it is recording. So we're good. So yeah, so as I was doing these reviews, one thing came up is that I started getting feedback from TAs and Dr. Tiagi about the fact that for the first, I guess, 2 PA and to an extent PA3, I gave a little bit too much code, and that caused some problems. So I just want to change the format a little bit, in the sense that instead of giving you my code, which, to be fair, I understand that it's it might seem better right now, but it's actually very harmful, especially when I'm doing PA4. I realize how harmful it is, because when I took it with Dr. Tanzir, he gave us most of the code. So we really just copying down and didn't really understand much. So it caused me a little bit struggling when I was programming this assignment. And I would actually tell you in a bit, but for this case, then for this PA and then future PA, what I will do instead is I will lay out the entire problem and what exactly you need, like the way to understand the problem fully. And then I will tell you some tips, or saying that, hey, this might not work. You should try to do another way. So instead of giving you your entire code, you still can learn, but it's just that I can't provide you as much code as it used to be, because that's obviously kind of cheating. So please review all the provided material. There are a lot of materials and help on Canvas. And then I will be here to give you some more hint and some more overviews so that you can see the problem overall in a fast, quickened way. So PA4 is 3 ways IPC. So it's just PA1, but now instead of using one IPC, you'll have, instead of using one way of doing IPC, FIFO, you have 3 ways. So you just have to find the other 2 ways. You have to program them, and that's basically the whole problem. And then yes, you have to adapt your server a little bit and client a little bit, but overall it focuses on the 3 IPCs. So let's look at an overview. So we have, the goal is to introduce you to different IPC methods. So you have FIFO, message queue, and shared memory. All this is already covered in lab, so I won't have to go over it too much. So you want to make sure that you construct 3 different IPC method in 3 classes, along with the request channel class. Modify the server and the client, and then check to ensure similar or better performance. And if you put in some work, this should be done in a few hours. That can cause, it can be go to a few days. That's fine. But if you focus, it's around 6-7 hours. So it's still a lot, but a lot better than PA3. So let's talk in detail. 3 IPC, you look at this, you have a base class of request channel, you have FIFO, which is already written for you. You don't have to touch anything. You have message queue request channel, and then you have shared memory request channel. So in this case, you have a base class right here that's spawned into 3 not subclass, but 3 classes inherit the request channel and do their own things. So let's talk about request channel a little bit, just slightly. So in here, you have a few virtual functions, and then you have my name and my side. So basically you want to put the name of the pipe in here, and then the side in here, and then you use it to create the C read and C write. So that's quite simple. So C read and C write are virtual, so you will use them to adapt in the inherit class, the child class, and then you just override them with the actual relevant information based on the class itself. So that's it. It's explained to you in lab. So I hope you. If you have any questions, just ask me after, and that's fine. And then we talk about FIFO. Oh, well, I guess it's already written for you, and most of the things you already learned from PA1. So if you have question, let me know after class, or just go and look at previous weekend review and resources. And then for message queue, so in this case, you have 2 message queue. 2 message queue, 1 to control. It's just like FIFO, but now you can only put, let's say you plug in 1 channel right here, then it will plug it out, and the size of the message, which I will talk in a bit, depends on how you code things. That the buffer you put out, there might be some problem that is unique to message queue that we'll talk in a bit, but basically the operation is very similar to FIFO. So as you can see, there's a problem that you might encounter with a message queue, is that, let's say if you get an ECG number and pass in the size of double to the C read function, you'll get the message too long. That might seem a little bit strange, because technically your message is smaller than the message queue size. So why is it telling you that it's too long? Well, you realize when you look at the man page is that the message length argument, which is the second argument in the buffer, point to argument specify the size of the buffer, point to message pointer. This must be greater than or equal to message queue message size attribute of the queue. So let's say your actually, let me actually give you a paint version so that it's a little bit easier. So if you have a message queue, let's say this is a queue, and let's say it's a message queue, and let me put it bigger a little bit so it's easier to see. Actually, this is fine. So let's say the size of this is 512. Okay, so then you plug. Then when you read it out, if you use, I think, MQ receive, I think that's the name of the function, then the buffer that you want to pass this in must be the same size or bigger than the value 512. So if let's say if you have a buffer of size 1000, that would work. If you have a buffer size of 500, that would not work. Because why are we doing this? It's because to make sure that regardless of the size of the message, let's say even if your message is 200 bytes, it's still be able to 200 bytes, because we don't know the actual size in the MQ received beforehand. You have it's a catch-all solution by being, if you have a buffer size that is larger than the specification when you initialize the class, it should be able to plug in. So this is a catch-all solution. So this is the specification of message queue. So you have to deal with this. You cannot just pass in a double. If you do size of double, you know that it's like, I think 8 bytes. Yeah, that would not work, because 8 byte is definitely smaller than 512. So what you have to do is, so now let me go back. Oh, that's not the right one. Yeah, I would just put it here. So you want to make sure that the message requirement, make sure the message pop from the queue can be put into the buffer regardless of the size. Okay, so you need to make sure the buffer that you put the message queue receive in must be bigger. Why am I emphasizing this? Because in the lab, a lot of people had this problem. So this is very important that you'll be able to see why. And this actually gave me a lot of trouble when I coded it. So to deal with this problem, you want to make sure you have a middleman buffer of size M, and then you would use C-read to from the queue. After you do C-read from the queue, we use memory copy to copy the data from the buffer to the ECG double value. And then when I did this assignment, and this is where I told you, Vak, is that if you given an answer, even though it makes your life easier at that specific point, in the future, when you try to understand this again, you won't understand it, because you're like, oh, I just be told to hard code it. I don't know what exactly it does. I didn't know that until yesterday at 12 a.m. rather. So this is quite something that I learned, and that's why I learned that it's easier to teach you the way than just giving you the answer. For this assignment, this might work on this assignment, but it can cause possible data corruption. And this is what Gabe told me, and I think that's understandable. So what you have to do is, if you have a size 5 message receive queue of 512, you should make a buffer. So let's say a car buff equal to new car. And let's say you want to make it bigger. So you want to make sure it's like 1,000. So if this, or if you want, it just need to be equal to, so buff size. And then you would receive the data, plug the data from the message queue, pop it, put it here. Then you would do mem copy. Then you would do the whole thing here, and you would do the ECG number value, ECG, like the ampersand ECG, and then you would put in the buffer, and then you do size of double. Then this would work beautifully. But if you don't, it would cause too long of a message problem. So that's something that I think is the biggest problem in message queue that I saw from people. Besides that, the class itself is relatively simple to implement. There are a lot of documents online that you can use, and I think the lab materials give you a lot of hint on how to do this correctly. So the only thing I want to enhance is that, yes, this is the problem that you need to make sure you resolve. Does that make sense? Do you have any problem? Do you have a question? I see some unmute mic chat. I think would due to the fact that you still have to, I think when you receive the message, you have to pull the entire message out. and then sometime it might have garbage at the end. Let's say you want to just get the double, it might cause problem for, let's say, file transfer or something. Like it's actually usually not a good practice to hard code things, because sometimes it's very not very robust. So that's why it's not recommended to hard code the value at all. So like you're saying hard code, let's say you do 8K in it, then it guaranteed that every time you do it, it would be big enough. Oh, yes. Okay. Yes. That's what the assignment say. And then I talked to Gabe yesterday, and if you don't have Gabe, that's he's told me, and actually I can pull it up right now. Oops, oops. Yep. Please ignore all this. He said right here that for the attribute, it should not be hard coded to 512, because I asked him the same question. Oops, I think that's some code. But basically, you can see right here, I hard coded to 512 right here. And I say this giving a lot of people a lot of issues. Basically, if you try to directly read EC a double, it will fail to message too long. While hard coding the message receive paragram may work with the PA, it's generally a bad idea, since the better approach will be an intermediate buffer that can fully receive the message and then parse necessary data out of it. So yeah, I don't. Yes, so that's what I think. This assignment instruction is somewhat adapt from Dr. Tanzir assignment. And when he wrote the assignment, he told us, when I took this class, he told us to hard code it. But then when I tried to help others on Friday, people said, "Oh, yeah," but nobody told us to hard code anything. So everyone I see have the instead of 512, they just put in the actual size of the message. So message, I think it's like buffer size or message size rather. Yeah. So if you code like that, yes, you can do 512, but I don't know how it would jeopardize your grading. That's what I'm trying to say. Yeah. Yes. Yes. If you do buffer size larger than 512. Yeah, it's just something to keep in mind, basically. That I think it's fine, but I don't recommend it, basically. That's what I tried to say. And of course, you should go and talk to your TA, because they are the graders. So, or not the, yeah, and they will determine if that's acceptable or not. But yes, this is a proper way of doing it. So any other question? Yeah, so thank you for the question, Peter. So I guess I will continue, and then we will have time for more questions, because I know that y'all have other questions you want to ask. So MQ send does not encounter this problem, because the message type can be between 0 to MQ size. That makes sense, because when you do MQ send, it's basically put a message into the queue of the size that's already determined for you. So it's like a box. You can put more things in, or you don't have to put anything. But when you take it out, you have to make sure you take it out and put it in something that is big enough. So that's why we have the catch-all solution of having a buffer larger or equal to or larger than the message queue size. Okay. So any other question about message queue? And that's the only thing I have for message queue, because other than that, I don't see people with have had trouble doing this assignment, doing this part. All right, no question. Okay, I will just go, and then y'all can answer ask question more privately. I understand. So for shared memory, now this one is a little bit, you have to deal with semaphore. That makes sense, because with message queue, the controlling, the preventing from multiple things to happen at the same time, race condition is already taken care for you. But in shared memory, it's basically just a block of memory that is shared across multiple processes so that so I think it's to improve performance, because accessing memory is so much faster than accessing disk, which are the way FIFO and message queue work, or live where they live. So this way it's a lot faster, and it might show in the program. Although I don't think it'd be a big improvement. But basically, you have a client and server, and you have two message queue, one for reading and one for writing. I mean, in the perspective of client, is that one for reading, one for writing. That's all it, and all of them live in memory. That's it. And because it's just a block of memory, you need to have a way to control the writing and reading process, or you would get into a problem similar to, let's say, a previous PA where you have underflow or overflow. So that's why you need a message. So you have a shared things to include. You have a shared queue class, implement the queue itself. So you have to implement this exact queue in here. And then you have all these functions that you should use in your queue. And then for a shared memory request family, it's just basically a wrapper for two shared memory queues with send and receive function plus, oh no, it's already have the semaphore is implemented here. So send and receive function. That's it. It's just a wrapper for shared memory queues. And then things for watch out. So these are the things that I saw when helping people. First thing is you want to make sure the two shared memory segments that you created to have two different names. Because if you have the same name, so then the semaphore would look at the same exact queue, and they would cause conflict with each other. And then make sure you are writing. The second thing I noticed is that some people or some student writing direct create the file descriptor, and then you write directly to that file descriptor. That should not be the case, because you're just writing to the disk again. So it might pass all the tests and you still communicate data properly, but it defeats the point of the shared memory queue, which is to improve performance by moving all the communication from disk to memory. So those are the two sections. And I think Zeke will put an announcement, or he already did, to say that you should not do this, because if you do this, you get points off. So don't write it to the file descriptor that you created. Write it to the memory segment. And I think you will even have to close it before you can start the writing process. So anyway, so that's something that I noticed. And then, so those are the old 3 IPCs. Any question about the shared memory part? That if you have like a specific code thing, we will talk in private. But if you have any question about it, let me know. Like a general question that I can answer. All right. Okay, it's fine. Okay. So I will go real fast. Okay, so adapt the server. So in the server, there are a few things that you need to change. First of all, you need to make sure all the FIFO, because you see the server has all the FIFO requests everywhere. You need to make sure you import the other 2 IPC first of all, and then you need in the include section, and then what you want to do is you change the name from FIFO request channel to just request channel, because that's the base class for everything. So then make a global variable for IPC method, so that you can switch between IPC method, or you can passing it in the IPC method to the process new channel request. And then you make sure you need to add the I flag with parameters. So I : into get opt for IPC method. And then both in main and process new channel request should have either switch cases or if else statement to switch between IPC methods. Is there any? So I think these are the only thing I saw that you need to change in the server. Is there anyone having trouble changing anything in the IPC server? In the server part? All right. Okay. I will just go to the client. So for the client, again, you add the I for IPC method, and make sure you pass it to exec VP or whatever exec flavor that you use, to make sure you have both I and M. And then add the C flag for multi-channel and data data and file transfer. Now, this part I think may confuse some people. Is there any question about the C flag that you need me to answer? Okay, okay. So then you need to make sure you use the same if else structure as the server for switching between IPC method. I think for this one, you need to do it for the control channel and for all the C channels that you need to create. So those are the two places you need if else statements. If you have a better way to just use one if else statement, that would be fantastic. Please use it. But I had to use two if else two if else, not statement, but if else blocks. So one for the control channel and one for the channels array or array list or vectors. As a reminder for MQ, ensure that you have a middleman buffer for requesting small amount of data. So if you have, make sure that you don't just pass in a size of double into C read, that would cause message to, because you're trying to pop in you're trying to put in a buffer of size 8, something that has size 512. That wouldn't make sense, right? So make sure that you have a middleman buffer and then use memcopy for this part. And then a bit about multi-channel file writing. So when I took this class, we did this PA before multi-threaded server one, and that means I never had an experience before this to do the file writing part, and I could not get OF stream to work. Now, if you can get it to work with multiple channels or multiple stream working on the file at the same time, then that's great. But if you cannot, you should try to find an alternative approach to opening for the file. Originally, I would tell you the exact way of doing it, my way of doing it. But after talking to TA, I think that's just, again, it's just not the way to do things. And that I completely understand that. So I just want to encourage you to try to learn how to do this if you cannot get OS stream to work, that's completely fine. That's not your fault. Well, it's the problem that you need to do. It's not something that, I don't try to force yourself to use OF stream. If you cannot get it to work, go find a different solution. And I'll get you one single hint is that it's something that you can, I guess, you go in out and there's way to use memory to do this problem. But I encourage you to go out and find a better way for many things to work on the same file. So just a conceptual thing, I will draw this real quick. Let me make a new one. Oh, I don't save. Let's just make a new one. So let's say if you have a file, let's say you want to transfer a file 1.csv. With OF stream, you can only get one header at a time. So let's say if you want to, I think you don't even get one, but basically the goal is to have many things that can write to the file and work with the file, and each of them has different chunk of to do. So instead of, let's say you have 3 channel and this file is this, then you want to divide this into 3 sections. And then the first channel write to the first section, and the second channel write to the second section, third channel write to the third section. So you have to iteratively go through all the channel and make sure the work is distributed properly. Now, I don't think you're gonna see any performance improvement. It's just that it's supposedly that the previous assignment would be the next assignment, so that you would understand, you can do this to improve performance. This should not improve anything because you still write things sequentially. So it's just something that I want to give you to understand the problem. So your goal is to get the first channel to write to the first part, the second channel to write to the second part, and third channel. So let's say if you have a file of size 300, then from 0 to 100 would be the first one, then 101 to I think 201, and then 200 rather, and then from 201 to 300. So yeah, so that's your goal. And I think that's it. That's all I want to tell you about PA4. And that's actually all you need to do. Any general question I can answer? Does that make sense? Does this make sense to you? Is there something that I'm confusing you? If I am, let me know. Yes. 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 So and let me pull up. I think I put it in week 2. Let me make sure I'm telling you there's the right one. Yes, I think it's right here. Oh, yes. So the way you do it is you just have time and you just put the run it again. You just run the same thing as normal, just put the time in. And I think then you would use I think you use sys. It's real or sys. It's one of them. Um, I think it is real. I think because sys is like switching context as well. It's one of them. Basically, I think even if you don't know, just use the one that you can scale. Like you can see this one, as the buffer goes up, it goes down. So as long as you can see a performance timing like this, that's fine. Yes. So, but it regardless, you can see that even you use real, it's relative to each other. You can see that if I double the size of the buffer, the system time decreased by half. So 10 to 6 and stuff. So yeah, you can use one of them. And just as long as you can see a trend in your graph, that should be good. Is that good? Is that good? Okay. Okay. Is there any other question? Because I know y'all have some coding question. Now, I will tell you, we have 1, 2, 3, 4, 5, 6, 7. 7 people, and I have 30 minutes. What I will do, actually, you know what? I have a conversation with Dr. Tiagi at 9. So, do I want to do it today? I guess I would just try my best. So basically, I will probably host the office hour until like 8:30 instead, because I know y'all have, and not last week I couldn't do it. So I will do office hour from to 8:30, and then if I feel like it, I will do it until 9. Just okay. So I will make actually I will just keep this room. What I will do, I wish there's a way to put y'all in queue, but if that's not the case, can y'all put yourself in queue if you have other question? And then I will just I will go through the queue and try to help. But yes, 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 yes. I'm glad. Thank you. All right. Have a good day. All right. So I will stop the sharing. So if you have any question, please put yourself in queue, and I will check the queue. And then if you and then I will call you back. Just whenever it's your turn, I will call you on queue. But yeah, I think we're done. So let me end the meeting.